Here are a few examples in the homework which may not have been referenced completely within my notes for the competency exam review. One of them here says, find the degree of the polynomial. The degree of the polynomial is the highest power in the polynomial. We're going to discuss what a polynomial is later as a polynomial function, but essentially something like this that has x's raised to powers like 5 or 3 or 2, it doesn't have division by x or anything like that, will be a polynomial function. It's just a bunch of terms added and subtracted together. So if you want to know what the degree of a polynomial is, you'll look for the highest power, which in this case is 5. On a question like this, it says multiply using the rule for the square of a binomial. Now, a binomial is a two-termed expression. So that's what we're squaring here is, in this case, I'm going to show x minus 9. That's two terms, and so that's what we call a binomial. To square a binomial, you have to multiply it by itself. So it'd be x minus 9 times x minus 9. We would do this one way, is to FOIL it together. So we're going to multiply the first, that'd be x squared. The outer would be negative 9x. The inner would be another negative 9x. And then the last would be negative 9 times negative 9, which is positive 81. So what this would look like is x squared minus 18x plus 81. And I have a few other examples of multiplying these together in my other review videos. Okay, this one's a slightly different way of describing how to do the question. It says simplify the rational expression. Find all the numbers that must be excluded from the domain of the simplified rational expression in order for it to be equivalent to the original expression. So this thing is to simplify, and in order to simplify the rational expression, we have to factor it completely. I do have some other review videos about simplifying rational expressions, so I'll follow along in those types of process here. The first thing to do is to factor completely in the numerator, which there's a GCF of 2. And if I factor out a 2, it would be 2 times x minus 3. Now the denominator is a trinomial, it's 3 terms. So we have to factor it like something like the AC method or something like that. And if you'd like to try that on your own, you might want to pause the video, and in just a second I'll go ahead and write down how it factors. This one would factor to be x minus 3 times x minus 3. In my other videos, I do have some information on how to factor with the AC method. Now what will happen is we can actually cross out an x minus 3, and that would simplify it down to 2 over x minus 3. Now the question in the homework, this is not something I would usually ask when we do this a lot of times, but it says what needs to be excluded from the domain. We'll talk more about this later when we actually are specifically thinking about the domain in a later section. But just for this question alone, we have to basically solve the denominator equal to 0. So our denominator, we can take this x minus 3, set x minus 3 equal to 0, and solve for x. All we have to do is do a plus 3 over, and it would turn into x equals 3. So that would be the number that we have to not use, that must be excluded, in order to make this thing work, because if it's not excluded, then we'd have division by 0. Something else you might see in a homework example is this thing. This stands for the absolute value. So for example, absolute value of, let's say, negative 20 is equal to positive 20. Basically, the absolute value takes any number and gives you the same number back, but always positive. You can see that also. Another question, the homework might look like something like 10 divided by the absolute value of negative 10. We consider the absolute value of negative 10 is just positive 10. So this would be 10 divided by 10 or positive 1. Something else in the homework is scientific notation and writing numbers in scientific notation. So the way we write a number in scientific notation, it depends on if we have a really big number or a really small number. And it's all about shifting the decimal point over one way or the other. So let's take 127,000. The decimal point is technically at the very end of the number. Scientific notation, what we'll do is we'll shift this number, scientific notation, what we'll do is we'll shift this decimal point over to the left until it's right behind the very first number. Let's count how many times we've shifted this decimal point over. It's 5 times. So in scientific notation, we write this as 1.27 times 10 raised to the power of the number of times we move the decimal point. In this case, that would be 5 times. So 1.27 times 10 raised to the 5th power. So I kind of wrote down here kind of what that means. We count the number of times the decimal point moved to the left, and we multiplied times 10 raised to the power of the number of times the decimal point moved. One thing that is important in scientific notation is if we move it to the left, then the power we use, which is 5, will be a positive number, positive power for 10. Now for this next one, so what we have to do here though is now the decimal point is way out in the front. So what we actually have to do is move that decimal point to the right until it's right behind the very first number. So we move it over 1, 2, 3, 4 times. Now when we write this in scientific notation, it would be 1.2, and we still multiply times 10, raised to the power of the number of times I shifted the decimal, but since I shifted it to the right, it would be a negative exponent, negative power. So that's the only difference when we have to move it from the left to the right when we're dealing with scientific notation.